Okay, so this video is for volume. So this is topic 5. This is packet number 4. The third and fourth topic were on the same packet. So find the volume of each rectangular prism. So there's a formula here on the side that you can use for the rectangular prisms. They will not give this to you on the formula sheet, but most people have this part memorized. The formula that is generic for every prism, any kind of prism, whether it's rectangular or some other type, is on the bottom here. So this is the one I'm going to use consistently because this is on the formula sheet. So if you can get familiar with seeing this and what plugging B in is, it's going to be really helpful moving forward. So we're just finding the volume of the rectangular prism. So volume is going to be BH. On the formula sheet, it doesn't tell you that this is the volume of a prism. It just tells you that this is the volume. Okay, so what we want to do is figure out what is the base shape. So the base shape in this is a rectangle because these are all rectangular prisms. So I'm going to shade in the base here. So what this capital B is an area of the base. So we need to basically figure out what the base shape is, which is a rectangle, and then we're going to use the area formula for that shape. So in this problem, we're going to have BH for the rectangle and then H. Now the H's are not the same necessarily. So H in this is the H of the rectangle. So the first H, H isn't the same. Okay, so this is the height of the rectangle. So the base and the height of the rectangle would be 17 and 9. And the height here is the height of the prism. So this is the prism's height, which is basically the distance between bases. So this would be the base and this would be the base. So the distance between those would be this segment here. So 24 would be my height that I plug in for the height of the prism itself. So 17 times 9 times 24 is going to give me the volume of 3,672, and this was in centimeters cubed. Okay. So we're doing the area of a rectangle timesing that by the height. So really what we're doing is we're taking the bottom of a surface, we're covering it, maybe with water or some other kind of maybe sand or something, and then we're filling that up, and that tells us how much it holds. So doing the volume, which is volume is going to be area of the base shape, whatever shape that is, timesing it by how high it is being filled up. Okay, so 2 and 3 are going to be very similar to this. You can consider any side to be your base since they're all rectangles, but I'll just make this my base. So my volume is going to be capital BH, and the base is a rectangle. Okay, so the dimensions of this rectangle are 4.5 by 10. And then my height is the distance between bases, which is the 14 here. So I get 630 when I do the multiplication out. So I'll let you do number 3 on your own. But then coming down here to these other type of prisms. So anytime it's any other kind of prism besides a rectangular, you still can use that formula that we've been using. That's why I used it, because that's on the formula sheet. So your base, though, is you have to recognize the bases from the very first worksheet that we did on the, not the first worksheet, the 3-dimensional that we did on the surface area worksheet. The bases are the parallel congruent faces. So you need to be able to identify on this shape what 2 sides are the same and are parallel. So a lot of people think, okay, the rectangle's on the bottom, that must be the base. Well, it would need to be parallel to another rectangle up here, and there's no other rectangle that's parallel to this. So it's not the rectangles. The bases are actually these triangles. So we have a triangle here in the front, and then the triangle in the back is parallel to that. Those would never cross, and they are congruent, equal in length. So our volume is going to be capital BH, and in this case, the B is a triangle. So every single time we have a B, we're replacing it with a polygon, really whatever the base is. So the base shape is a triangle, so we put in a triangle here, and we're going to use the formula for the area of a triangle. And again, this H is the distance between the bases, the congruent bases, congruent parallel bases. Okay. So basically it's the width of the figure. Alright, so the base triangle, so if I'm just looking at the triangle right now, I don't care about anything else when I'm doing this part. I'm just looking at the triangle's base and height. So we have 12, this side is 10 and 9, and then this side is 7.3. The base and the height on this triangle have to be perpendicular to one another. So I need to use the 12 and the 7.3 as my B and my H for the triangle. Then the height of the prism is the distance between triangles. So there's a measurement of 5 units here between the triangles, so 5 is what I'd be multiplying this by. So 0.5 times 12 times 7.3 times 5 gives me 219 feet cubed for my volume. So again, all of these, you're going to be using capital B. The capital B gets replaced with whatever shape the base is. So on number 5, take a second to consider what would the base shape be. Okay, if you said triangle, that was correct. So we have volume of capital BH, and the capital B is again a triangle, and the H is the height of the prism, which is the distance between triangles. So the triangle's area is 1/2 BH. Again, the H's are not the same. This is the height of the triangular piece that I've shaded. This is the height of the prism itself, the width of the prism. So 1/2, the base, I need to look for a perpendicular set of sides. So this and this meet at 90 degrees, so my height and base are 11 and 5.4. And then my height of the prism is how many units are between parallel congruent faces, so the 16. So 0.5 times 11 times 5.4 times 16 is going to give me 475.2, and this was millimeters cubed. Okay, so the process is the same for volume throughout. If you are given if you are missing a dimension, so say they don't give you the base here, then our method to find any missing dimension is Pythagorean theorem. We need to find a right triangle and be able to cut the figure up as whatever way we need to find a right triangle and solve for the missing side. So I'm going to do number 7 because I believe, no, number 8, because that one involves Pythagorean theorem, and so does 7. Okay, so both of these are going to involve Pythagorean theorem. The harder of the two is 8, so I'll do 8. Okay, so go ahead and identify the base shape for number 8. What would that be? Okay, if you said trapezoid, that was right. So that's the base shape. There's 2 trapezoids that are equal in length, parallel to each other, equal in measure, sorry, parallel to each other. Okay, so on the trapezoid we have this. 25 is this side, 30.6 is this side, and 39.4 is this side. But we are not given this bottom side. We should not assume that it's 25 or 35. It could be anything. Okay, so what we want to do is we want to do the volume is equal to capital BH, and the B in this case, the shape is a trapezoid. So we're going to put in trapezoid here, and times it by the height of the prism, which is the width between trapezoids, so 35. Okay, so the trapezoid's formula, if you have that memorized, is this. So we need the height of the trapezoid and the bases. Okay, so looking at this picture of the trapezoid, the bases are always the parallel faces. So this trapezoid is actually standing on the wrong side. So the height is the distance between the bases, so this would be the height. We don't have it, so what we want to do is we want to cut the trapezoid here to make a triangle, and then figure out what this length is. That's going to be our height between the two bases. So 39.4 is the whole thing, and 25 is this piece, so we want to do 39.4 minus 25 to get this piece is 14.4. Alright, so we're going to use this triangle to do the Pythagorean theorem to solve for the h that we need in the trapezoid formula. Alright, so if I do that, 14.4 squared plus h squared equals 30.6 squared. So I'm going to do my 30.6. So you should be very familiar with solving Pythagorean theorem at this point if you're in my class, because we do this a ton. Okay, square rooting both sides, you get h is 27. So that's why I skipped some steps. Normally you would I would show all the steps, but because we've done this so often, I'm hoping that by now I don't need to do every single step out for the height. Okay, so that's the distance between bases, and then the bases are the two parallel sides, so 25 and 39.4 in this picture. And then 35 is the height of the prism, which is the width of the prism. Okay, so we're going to do 0.5 times 27 times parentheses 25 plus 39.4 times 35. Just 35. So it's 30,429, and it's in centimeters cubed. Okay, so again, process is to figure out the base shape, put that in for the B, figure out the area of that base shape. If you don't have a dimension, like we didn't get the height between them, we need to use the Pythagorean theorem to solve for the height. Then we can use the dimensions for the trapezoid, times it by the height, which is the width of the prism, and we're done. Alright, for the volume of each cylinder below, we are going to do the same formula, even though there's another formula written here. I'm going to be consistent because this is the only formula on the formula sheet. And a circle is the shape of the base. So I'm going to be doing the area of the circle and timesing it by the height. Well, the fortunate thing about this is all the dimensions are given, so I just have to multiply all this. So 18 squared times 15 gives me the answer in terms of pi as 4860 pi. Timesing that by pi to get the exact, this is the exact answer. To get the answer to the nearest tenth would be 15,268.14, and it's in inches, so this is inches cubed. Okay, so that's the cylinder. So same process, same formula, just to circle your circular base. Okay, 11 and 12, they want a cylinder with a 2 centimeter diameter is drilled through a triangular prism. So you have a triangular prism originally started off with, but they drilled a cylinder through the middle of it. Find the volume of the prism. So since they've drilled something through the middle of it, that part of it is gone. So what we're doing is we're taking the volume of the triangular prism and subtracting out the volume of a cylinder. Okay, that's the triangular prism without the bored hole of a cylinder from it. Okay, so the triangular prism is going to have a base of a triangle and the height. Sorry, I should have put the it's capital BH, but the triangle is the base shape. And the cylinder is a circle with the height. So the triangle is 1/2 base times height. Again, this height might be different. And pi r squared times height. Okay, on the triangle, the base and the height always are perpendicular to each other. So there's this little right angle here, which means these two sides are the base and the height of the triangle. Okay, so basically if I were to redraw the triangle, 5 and 5 would be your base and height. The height of the prism is 14. Okay, for the circle, for the cylinder, it tells us 2 is the diameter. So 2 is the diameter, which means the radius is half of that, or 1. Okay, and then we just go to our calculator. So 0.5 times 5 times 5 times 14 minus pi times, 1 times 14. So our answer is 131.02, and it's centimeters cubed. Okay, so that would be the volume of the triangular prism without the cylinder. Without means taking out or subtracting out the cylinder. Okay, and then finally on this page, Eric's pool is shown to the left. He plans to fill his pool to a depth of 4 feet. So even though the pool is 4.5 feet, his water line is only going to be about this high. All right. So it's 4 with the garden hose. So that it has a 80 cubic feet per hour flow rate. So how many hours will it take to fill the pool? So it's only pouring in 80 cubic feet per hour. So what we need to figure out is the volume of the water that he needs to fill the pool, the tank, and then we need to divide that by 80 because it can only do 80 cubic feet per hour. So if the volume was 160, he could do he could fill it in 2 hours. But we need to figure out the volume first. So the volume of water is going to be capital BH. Capital B in this picture is a circle with the base shape. And the circle is pi r squared. Okay, so we're substituting that in for circle. Alright, so the radius of the circle is, the radius is only from the middle to the edge, so it's 27 divided by 2, or 13.5. And the height is only 4 because that's how much water is needed, even though the tank is 4.5. Okay. So then going to our calculator, we have pi times 13.5 squared times 4 divided by 80. So he needs about 28 hours and some change. So he needs 29 hours if we're doing it per closest hour. So 29 hours, which is really 28.6 hours, but it's going to take him 29 hours to do it. Especially because, yeah. Okay, so that's the volume of prisms. The volume of pyramids is similar. The formula only has divided by 3. That's the difference. So 1/3 of the volume as if it was a complete. Okay, so if this was a complete prism, sorry, that's such a bad drawing. Wow, that's terrible. Then you would have that volume, but you divide it by 3. So what we need for this is, again, whatever the base shape is times the height. So in this case, the base is a rectangle. So I'd use a rectangle area for the B and then H. The rectangle's dimensions are 10 by 11. So I'm going to put in 10 times 11 here. And then the height of the prism is 16. So that's how tall it is. Okay, so I'm just doing 10 times 11 times 16 divided by 3. Alright, so some of them are going to be pretty straightforward, but not very many. What you'll need to do is figure out missing dimensions if they don't give them to you. So on number 3, for instance, they give you the dimensions of the square base or the rectangular base, whichever one you would consider it. It's got the right angle, so it meets the qualifications for both square and a rectangle. But they don't give you the height. So they don't give you this dimension, which you do need the height to get the volume. So you need this height. This is not the height of the, this isn't how tall it is, this is the slanted distance. So what we want to do is create a right triangle that has the 25 in it. It has half of a side. Okay, so 7 is half of 14, so this part would be 7 here. And then H, which is the height of the pyramid. Okay, so we're going to do our Pythagorean theorem. Our 7 is B or A, and then 25 is C. Okay, so H is 24. Okay, so now we have everything that we need. Okay, so the rectangle or the square's dimensions are 14 by 14, and the height we found to be 24. So we do 14 times 14 times 14, and divided by 3. My computer timed out on me. Okay, so the next one I'm not going to solve all the way out, but I am going to give you some hints on the height and the base. So the bases are pretty much on the bottom for all of these. Okay, so if I look at the bottom triangle, the shaded triangle, I had a 12 here, and then this was 7.5. So in this case, they've given me the base, and they've given me the height, so I have what I need, and then they give me the height of the actual, so I'll show I have what I need to get the volume. I'm going to skip that one. On number 5, this is my triangle base. And if I redraw it, they've given me 14, 90 degrees, and then 22.1. They don't give me this side, but the base and the height of the triangle are these two sides because they're the sides that are right angle, they're perpendicular to each other. So you'll need to do the Pythagorean theorem on this one to find out the side here, which is the base or the height of the triangle, and then you can use the formula. So again, we're doing triangle as our base shape. the triangle's area is 1/2 BH. So once we figure out the B and the H, so 14 is one of them, we need to do Pythagorean theorem to solve for the B. And then the height is 19. Okay, so I'll let you do the Pythagorean theorem and solve this for B, and then plug this in and solve for the answer. Okay, and then 6 is also not given the height. So this is 10 by 10 by 10, and it doesn't give us any right angles on this figure. So if it's a 10 by 10 by 10, the nice thing is that when you cut it to make a right triangle, this side and this side are the equal, because this is equilateral. So when you cut a 60 degree in half, this is 30. These were 60s. 30, 60, 90. Remember, the hypotenuse is double the length of the short side, so I know these are 5s. Okay, so we're doing the Pythagorean theorem between 5, 10, and H for just the base triangle. Okay, once you find that height, I'll draw it right here, and 10 is your base, so you're going to use 10, and then 16, because that's how tall the pyramid is. Okay, cones is very similar, but it's just a different base. It's a circular base, so the formula is here. But again, the formula is 1/3 capital B is just a circle, so they're plugging in circle formula here, and H. Okay, you're going to have to use Pythagorean theorem potentially to find one of the missing dimensions, but I'll let you do that. Okay, actually I'm going to let you do the rest of it. It's time for me to go. Alright, good luck. Oh, let me flash the answers real quick. So the answers for the volume are here, so you can just check to see if you did them correctly.